Basically, it's looking like we're trying to figure out probabilities of more than one thing occurring. One or another. Event A or event B. And in order to be able to do that, we have to understand the vocabulary of how these are going to be worded. For example, if I just wanted to say, what's the probability of getting a diamond in a deck of cards? What's the probability of picking a diamond? 13 out of 52, so 1/4?
Yeah.
I know I didn't. I swear to you, I did. All right, now what's the probability of a spade?
Nope.
That's a spade.
Heart.
Yep.
You do that a lot.
What's that?
Kind of.
Yeah.
The black card is dead.
It's the dead heart, yes. So what we're looking at, instead of just doing that, we're going to look at what's the probability of stop. Or I will allow him to duct tape you. So we're going to look at this. Unions and intersections. Now, if I'm not mistaken from third hour, you don't have to write all this stuff out. You guys probably, watch out for those. You guys have probably worked with Venn diagrams, I'm guessing probably in a science class.
Yeah.
You're looking at two different events occurring, then sometimes there's an overlap in between the two. Well, what's happening here is that sometimes there's not an overlap. Sometimes you can have two different events that are occurring that don't have any overlap with them. Those are called mutually exclusive. So what we're going to be able to do here is, if I wanted to figure out the probability, let's say, flipping over a 6 or a heart, I want to figure out that probability today. Those are two different events, aren't they? Yeah. Do they have an overlap?
Yes.
Yeah. They have a 6 apart. So right now I'm looking at the probability of getting a 6. Well, that means it's the probability of getting a 6 plus the probability of getting a heart. But since there was something that is shared, what do you have to do? What's that? All right, what's the probability of getting a 6? So that's 4 out of 52. So if you're looking at it in terms of the Venn diagram, there's 4 4s. 1, 2, 3, 4, because that's a 4 of hearts, isn't it? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 total hearts. So the probability of getting a 6, there's 4 of them. There's 13 hearts. But what do I have to do to the one that's overlapped? Subtract. Do double counting. You subtract when they have something in common. So the probability of flipping over a 6 or a heart then would wind up being 16 out of 52. 826, so that's 4/13. See how there's something overlap? The 6, it can also has a heart. So the probability of getting a 6, there's 4 of them. Probability of getting a heart, there's 13. But I've counted the 6 of hearts, all right? So you're looking for this overlap. And this is that intersection, the intersection of those two. Yes, ma'am?
So, if it's an and, it would be multiplication.
We'll get some multiplication, stuff like that tomorrow. That's an independent event. These are different. It's a little bit different. So here's what's happening. What we're doing here is we're working with mutually exclusive or non-mutually exclusive probabilities. This is an example of a non-mutually exclusive. There is some overlap. So to find that probability, you just take the probability of event A, plus the probability of event B, and then you subtract out the probability of A, and B. Okay? Now, if I wanted to figure out probability of flipping over and getting a 4 or a 5, those are completely independent or exclusive of one another, aren't they? They don't share a commonality to it. So if I wanted to look at something where it's the probability of a 4 or a 5, well, what's the probability of flipping over a 4? What's the probability of getting a 5? So that means my probability is, they don't share any of that. They're completely exclusive of one another. Which we found out to be, what was it? 4/26, 2/13. All right, 4 or 5, ready?
Just 4 parts.
Oh, it is.
Use 13.
Okay.
I'll do
That's
another one.
the difference.
Next one's in the.
Yeah, one more.
That's the difference here. You're looking at the wording of it. Is there an overlap? When they are mutually exclusive.
Yeah,
When they're mutually exclusive, it's just the probability of event A plus the probability of event B.
Let's try one more time. See if you get
4 or 5?
Yeah.
Oh!
That was well played, guys. I thought for a second there I was going to win.
It's like,
Try
yeah,
11
I-
more times.
You can't play it.
Yeah. Your mental data is equal to.
It's a 4. All right. So let's look at this. You wind up with these two different types of probabilities for compound events. We already have them up on the board. The one for mutually exclusive is the one that you don't have to worry about backing out something that they shared in common. When then they have something shared in common, that's when you have to back stuff out. It becomes very easy to work with when you work with these, especially with decks of cards. That's what most of these problems look like. So let me show you another example then. Oh, we'll come back to this one. So if I'm looking at this, well, let's worry about that later. Card is randomly selected from a deck of 52. What's the probability the card is an ace or a face card? Well, how many aces are there?
4.
How many face cards are there?
12.
12. So if I want to find the probability of an ace or a face card, well, there's 4 out of 52, 12 out of 52. Are there any of those overlapped?
Nope.
No. So your answer would be 16 out of 52. I'll make this more interesting. I'm going to flip over 2 cards and you won't see them.
Oh.
I saw
Write
it.
down what you think they are.
Willis, this is your
Oh.
chance,
Wait, be specific about like
6
Yep.
Number answers.
Yep.
6 to
Yep.
8.
6. That's like it.
Sure, absolutely. Write it down.
Oh, I got it.
Wait, how much extra?
I don't know. You don't have a very good chance to get it right.
So 5.
I got it again.
So only the number, not the shape.
I need to know exact card.
I got it.
I win.
Suit and number or
That's
face.
so hard.
I got it.
Wait, hold on.
I
Is
got
it
it. The chance of that's.
I got it.
I got it.
This is actually more of a.
I think this is the
Probability.
It's
Any located
is
in
one
out of let me see.
This is actually a probability we're working on tomorrow. These are independent events. This is stuff we do tomorrow.
I don't mean to be
I thought it
rude
was
or
funny.
anything, but this is exactly.
Does anybody have a 4? Well, you're lost because it's not a number.
Okay, what is it? What are they really?
How about a king?
Oh,
You have a king of what? No, It's not king of spades, it's king of clubs.
Oh.
Anybody? Anyone?
What's the next card?
Nobody?
Bet one of those. Yep.
I said.
I put number seven.
Yeah, Dave? 8 of clubs?
I put
Number seven.
Yeah.
I had a 6 clubs.
You were wrong, you lost. You lost all.
That's the
I bet you money.
I was feeling the A's,
All right.
dude. I was really feeling the A's.
Now look at the difference between that one and this one. Probability that the card is a heart or a face card. Heart or a face card.
Just aces counts.
No, they're face cards. In the book here, they're counting face cards as just kings, queens, and jacks. Okay. So I would look at heart or a face card. Well, how many hearts are there? There are 13. So you have 13 hearts out of the 52. We know that there's how many face cards? 12 of them. Now, what have we double counted? Three hearts. The heart face card, so what do we have to back out? Subtract 3. Good. Alright, so our probabilities are getting better. Still less than half chance.
I can't shop.
Can we guess? Can we guess? Can we guess? Can we guess?
I'll be fair.
You don't think I'm being fair?
Probably are.
Oh, that's the 4. 4 though.
I would get it.
I want a heart or a face card.
It's a heart of.
Oh, so we. He's much better at shuffling than I am. All right, heart or a face card. Let's go.
Spade.
Again.
Yeah.
King jack. King spade.
Willie.
It's a win.
10 is next. 10 is next.
The possibility of
Hey!
King diamond.
All right. So now we go back to something like this. What the book likes to do is to write these in terms of equations. The book likes to rewrite some of these things out in terms of equations to figure out the probability of A and B. Now, if there's an A and a B, is that going to be mutually exclusive or non-mutually exclusive? It's non-mutually exclusive. Very good. So what happens here is they like to write it out in terms of equations. Probability of A or B, probability of A plus the probability of B, back out the probability of A and B. So this is nothing more than 0.8 equals 0.7 plus 0.2 minus X. Is it 0.01 or 0.1? Like I said, these are extremely straightforward. There's not a lot of scariness involved here. One of the other things I want to talk about today is called a complement. It's not that you look nice. It's the opposite, if you will. Kind of. You guys, I believe, saw this symbol on the Friday portion of the test.
Oh,
Daisy, can I go? I didn't know if you were ready. All right. Something called a complement. The probability of the complement of A. Did you guys ever see that little slash mark next to a probability on one of those questions? I remember seeing it.
I didn't know.
The probability of that is basically this. This is called a complement. This equals 1 minus the probability of an event. Okay? So if you wanted to say, what is the probability of not heart in a deck of cards? If I want to get the probability of not a heart, 3/4, right? A quarter of the deck is hearts. So what you would do here is a couple of ways of writing that out. You could take, well, 3/4 of the deck does that. One of the ways to solve that is, well, what's the probability of a heart? 1 out of 4. So they take it as 1 minus that 1/4 to get that. A lot of times it's quicker to work with complements to solve some problems than it is to try to list things out. That's why they use it. Okay? Complements are used to make calculations easier. What's that? It was tough. I really hope we get the results because I'd like to know how you guys did. Oh, I skipped over one.
I don't think anyone would have passed that test.
No, I was having a hard time with some of those questions. So let's look at one of these. When 2 6-sided dice are tossed, you get those 36 possible outcomes. So if I want to look at what is the probability of the sum not equal to 8, the easiest thing to do here is find the sum equals 8, and then take its complement. What I mean here is if I go through the deck through those 36 possibilities, the sum equaling 8 would be 1, 2, 3, 4, 5 of them. Do you agree? How many of them are not equal to 8 then?
How many are
One of them. So what you're doing here is you're working with the not equal to 8. So you find the sum that is 8, you take its complement. So the sum of 8 is what? The 5 out of the 36. Not equal to 8, we use the complement. 1 minus 5 over 36. It's a lot easier to work with that instead of having to count out 31 of them. Does that make sense why they use complements? It's not a necessity, it just makes calculations quicker. Okay? It just makes the calculations quicker. Same thing with where it says the sum is greater than or equal to 4. Well, if I want to go through all the dice to figure out where the sum is greater than or equal to 4, wouldn't it be quicker to figure out which ones are less than 4?
Yeah.
Well, how many of them are less than 4? 1, 2, 3 of them, right? Yeah.
I was only counting the red dice.
Oh, they're talking about the sum. So the sum, we would find the complement then, so it would just be 1 minus that 3 of them. You get 33 out of 36, which is 11 over 12. Okay.
Is there a complement button of it, or we just do it like?
Yeah, you just do 1 minus. Yeah, there isn't a complement button. You're just working with fractions. You can just do 1 minus, your alpha y equals. A lot of them you can. A lot of them you can. They're not really all that difficult. What'll happen here is when we get into a couple of the word problem style, it takes a second or two to understand how you set it up. The math part of it is very easy. It's just a matter of watching for your overlaps. Okay, with those exclusives and non-exclusives. So let me show you that example here. You don't have to write all this out. I'm just going to kind of read you what it sounds like. In this example, they're talking about a company that paid overtime wages or hired temporary help during 9 months. Overtime wages were paid during 7 months, and temp help was hired during 4 months. At the end of the year, an auditor examines the account records and randomly selects 1 month to check the company's payroll. What's the probability that the auditor will select a month in which the company paid overtime and hired temp help? So right there with the word where they're saying they hired temp help and they paid overtime, that means it's not mutually exclusive. Everybody okay with that? So they're talking about the first example. So you have your probability of overtime or temp help will equal the probability of overtime plus the probability of temp help minus the probability overtime and temp. See what I'm doing there just by writing it out? Because if I'm going back into the word problem, all that information is there. First line of the problem said that they paid overtime or temp help 9 out of the 12 months. They paid overtime 7 out of the 12 months. They hired temp help 4 out of the 12 months. There's your unknown. What do? You solve for x. It's 1/6. Yep, you get 1/6. A lot of people can do that in their head when you set it up like that. You get 11 over 12, and you need to make 11 over 12 equal 9 over 12. What do? You subtract 2 over 12.
Get it. Wait, what's the answer?
1/6.
Oh, yeah.
Or 2/12. What people are doing is they're taking that, and they see it's 7 and 4 is 11. 11 minus what is 9?
Job
2.
view.
You just write it out. The big idea here, guys, is to identify whether or not you have a mutually exclusive probability. If you have a mutually exclusive probability, that just means that two things, they don't share anything in common. It's that probability of getting a 4 or a 5. Okay?
What?
Now you tell me. The probability of what?
What?
Probability of Michael being foolish.
I think it's approaching 1.
Mr. Murphy, may I please go to the bathroom?
Probability of Michael being catfish. I agree. That's pretty.
So, go ahead and get started.
It's 7.
Yeah, that's what
Eventually we'll get there.
Oh, passing period.
Approaching 1.
Yes.
What else are we going to